In this section, we're going to see the static range sum queries. First, we'll see the problem statement, and then we try to understand that problem. After that, we're going to code the solution using a naive approach. Then, with the prefix sum array. And finally, we're going to practice on LeetCode online judge. Let's see the problem statement. Given an array of n integers, your task is to process q queries of the form. What is the sum of values in range AB? AB are inclusive here. The input, we have the first line in the input contains two integers, n and q, which n is the number of values and q the number of queries to perform on these values. The second line has n integers, x1, x2 until xn, which are the array values. Finally, there are q lines describing the queries. Each line has two integers, a and b. What we're going to compute the sum of values in range AB inclusive. The output is to print the result of each query. The constraints n and q are greater or equal than 1 and less or equal to 2.10 power 5. As you see here, the array is one based indexing. We have to be careful here in the code later. And the content on xi, and the content on AB. As an example here, it gives me 8. My array, the input array, contains 8 integers, and we're going to perform 8 range sum queries. These are the integers in the array. Then we're going to perform a range sum query from position 2 to position 4. From position 2 to 4, this is 1, 2, 3, 4. We have 6 plus 5, which is 11. This is for the first query. The second one, from position 5 to 6, 5 to 6, 2, 3, 4, 5, 6. We have 2, 5, and 6. Position 5, position 6, etc. We're going to display the output of the 4 queries here. Let's understand more the queries here. Let me remind you that we talk about the static range sum query, which means there is no updates. That's why it's called static. If we have here, for example, n is equal to 20, which means that my array contains 20 integers, and we're going to perform 2 queries, 2 range sum queries, or RSQ. From 2 to 6, from position 2 to 6, which means we're going to compute the sum from index 1 to 5, because in the problem here we have the array 1 based index, so we have to reduce 1 from the left bound and right bound. From 1 to 5 we have, as you see here, 3 plus minus 1 plus 5 plus 22 plus 10. It gives me 39. Another query, for example, here from 16, from the position 16 to 17. Here, as you see in the animation here, this one, which means from 15 to 16, 2 plus 4, this 2 ones, is equal to 5. This is our solution, or our code. What our code must do. Let's try first the naive approach. Let's take the left bound is equal to 4, the right bound equal to 7, which means we're going to compute from 4 to 7. I take here 0, the array as 0 based indexing. No, the sum is equal to 0 first. Then from position 4 we have 22. We add 22 to the sum and go to the next position, which is 5. At 5 we have 10, so we have add 10 to the sum. It becomes 32. And go to the next position, 6, position 6. It contains 30. We add 30 to 32, it becomes 62. And finally, position 7, we have 5. At 5 here, we have 67. The sum from 4 to 7, position 4 to position 7, is equal to 67. Let's try another example. From position 10 to 12, S is equal to 0 first. At position 10 we have 12, so we add 12 to 0. And on position 11 we have 0. We add 0 to 12 to remain 12. And finally at position 12 we have minus 5. Minus 5 we add it to 12, it becomes 7. Now this is the naive approach. This is the pseudocode. For each query, we're going to initialize the sum S to 0. And for each number x in the array from left bound to right bound, left position to right position, add x to S. And print S, which is the sum for the current query. Let's code it. Now here I'm going to use C++. Of course, you can use your favorite programming language. I prepare here all the inputs to gain some time here. First, I read the input array size n and the number of queries q. Then we read the values in the array input. We put the values in the array, and we run over the queries. We run over the queries. Here we read the left bound and the right bound, and we compute the sum. I'm going to use this function. I will create this function called the range query naive, which take as parameters in the input array the left bound and the right bound. Left bound minus 1, the right bound minus 1, because in the input in the problem statement here, it gives me the left bound A and B are 1 based indexed. And of course, as you know, C++ is not 1 based indexing for the arrays, it's 0 based indexing. And finally, I print the answer or the result of each query. Now, let's code this using the naive approach. We have the input array and the left bound and the right bound. We want to compute the sum from the left to the right. Initialize S to 0 and 4. I'm going to run over the array from left to right position, and we add the input, the current input at that sum. Input I to the sum. After that, we return the sum. Yes. When the computing is done here with this for loop, we return the sum. Let's test first and do two test cases. The first one is passed, as you see, and the second one is passed here. Now let's submit it on the online judge. Choose the file here. Range equals. I think this one. Okay, this one. Let's try it. Okay, as you see here, I have a time limit exceeded because it passes the first test, but the second test or the other tests are not passed. Here we have a time limit exceeded. This code give me the naive approach gives me a TLE, time limit exceeded. The question here, why? This is the question, this code, this function. Let's take this. Let's take all the comments here. Okay. Why did we get ATLE? Please leave a comment. And tell me why this code gives us a time limit exceeded when we submit it to this online judge. In the next section, of course, we're going to answer this question, and we're going to see how to resolve this issue.